Okay, so what I'm going to do is do a brief video to talk about confidence intervals. And one of the things that I want to show you is a couple of functions in Excel that are going to help you calculate what you need to get the information you need to answer the questions effectively. I'm also going to talk about how to interpret what you obtain. Okay, so let's go simple. I'm going to start with confidence intervals, and I'm going to create a small data set. So let me just do some random numbers here. Okay, I'm just going to pick a few numbers. And then we could pretend that this is a cost of a stereo, or perhaps some other, trinket that you want to buy, something you're interested in purchasing for a holiday gift or what have you. I'm going to leave it at 10 to make it simple for numbers. And so let's say that we got this information regarding a data set. So hint, hint, think of your project. Think of your project and the numbers I gave you. You can actually do this in Excel. So let's say I wanted to create a confidence interval for this information. And so one of the first things that I would ask you to do is let's find the average. Let's find the standard deviation. And then we're going to locate the margin of error. Okay, so I put ME for margin of error. So for the average, you hit equals average. Double click on it. Hold down your numbers. Try that again. Equals average. Double click on it. Hold and drag. Standard deviation equals STD, and then you want the third one, EVA, STD EVA for standard deviation. Double click on it. Hold your values. Okay, so we want to create a confidence interval. To do so, we need that margin of error. So what we're going to do is we're going to say equals confidence, and we want confidence T. Okay, let's go with an alpha of 0.05, comma, the standard deviation itself, comma, and the sample size, which is 10. Close that parentheses, hit enter. So that's your margin of error, 82.966, which is fairly large considering the standard deviation is 115. So you want to create the lower confidence level, LCL, and you want to create the upper confidence level. And so all you have to do at this point is say equals the average minus that margin of error equals that average plus that margin of error. And so your confidence interval is 221.336. Now, if you wanted to narrow this down, let's say hypothetically you want one single digit, we're going to go and we're going to make this smaller, bigger, it's up to you. However you want to make it. And so you would answer that your confidence interval is 221.3 comma 387.3, and that means that you estimate you are 95%. This is the interpretation, by the way. So you would say, we usually say we are 95% confident that the expected value or the mean or the proportion, depending, in this case it's not a proportion, so obviously you wouldn't use that, that the I would say mean falls between, and then you would state your values, 221.3 and 387.3. Alright, so that's how you would interpret. So this is the interpretation of the confidence interval, and there are a couple of ways that people vary this, so keep that in mind. You may see very similar conclusions, but that's the essence of it. One other thing to keep in mind, notice that our average is 304.3, and if I take 304.3 and I subtract 83, let me do the equals in front of it, sorry. You'll notice, what do you get? 221.3. And if I were to do the same thing, but this time add, so I would say equals the average, which is 304.3 plus my margin of error of 83. See? I obtained the upper confidence. So that's how we determine the confidence interval. And this gives us an estimate of the larger population based on the information provided. You can do the same thing with a p value. If you have a p, remember that you can find the average of a p-value. If you were to take the mu, the n times, the n sample size times the p-value, you can actually obtain your confidence interval. So let me do that down here. Alright, so this is for proportion, and this is using Excel. So if you are given a sample size of, say, 50, let's not use 50 because that's too easy. Let's do 72%, that's your p-value, okay? Or your p-hat. That means that q-hat, right, this would be equal to 1 minus 0.72, and that's your q-value, or your q-hat. Called q-hat. Let's say that this is a value that we project from a population sample size. Let's go with a nice clean number. Let's do something like 400. It's easy to do the square root in case you're using a basic calculator, not Excel. Okay, so 72 is your p-value or your p-hat. Alright, and so what we want to do then is we need to find mu, which is our average. So I'm just going to put this to remind you, mu is your average. And so this is equal to n, which is your sample size, times the p-value, which is 0.72. I have to type it in because I didn't do it without numbers. So that's your mu. And so we need mu, we need the standard deviation. Okay, and if you recall, that's going to be equal to the square root of p-hat times q-hat. So in this case, this is equal to p-hat. I'm just going to write it like this so you can times q-hat, and all of that divided by n. Okay? So, yeah, it's giving me a crazy formula because it's like, what am I doing with the p and the q and the n? So numerically speaking, this is just a formula. What you would end up doing here is you would simply say equals 0.72, do a parentheses, 0.72 times 0.28 divided by 400. I'm sorry, the square root of 400. Take that back. The square root of everything, because you're squaring all of this. So basically all of this is under the square root. SQRT. So that'll put everything under the square root. If you do double parentheses from here to here, you see how this highlights in red? So it's going to make sure that you actually have this product first. If you don't do the extra parentheses, like you see how these are dark out here? That's the whole formula. So it's taking the square root of everything. Now, keep this in mind. If you don't put those little red parentheses that you see there, what happens is this reads left to right. It may actually take the product, the quotient of 0.28 divided by 400 if you don't have the parentheses. So you definitely want the parentheses in. Okay, if you remember, the formula is p hat. So in our case, we're going to take the 0.72, and we have to do 0.72 minus the critical value, and that critical value times what we just computed here. Okay, so what you're going to do is, first of all, let's find the critical value, and since we're assuming 0.95, and confidence intervals are always two-tailed, we're actually going to use equals n for norm as dist. Equals n. Scroll down. We want norm s. Actually, norm s inverse. Okay. And so, again, confidence intervals are two-tailed, so we're really looking at 0.025. That will give us the negative. Or you can do the same thing, but this time use 0.975. So 0.975, you're going to notice it gives me the same number, but positive, because that's the positive side. But this is like right when you look at the normal distribution, and this is your left. Okay? Now, this case, we're going to say equals p hat, which is 0.72. Let's go with minus parentheses. We're going to do 1.96 times our standard error. And that should give us the lower confidence. We're going to repeat this formula, but with a plus this time. So we're going to say equals 0.72 plus, again, parentheses, just because we're going to go with the critical value times the standard error, which will be computed, close parentheses, enter. So my confidence for this, or the proportions, we would estimate fall between 0.675999 and 0.764. So we interpret this confidence as a percentage. So because I'm going to round this, this would become 67.6%, comma, and then this would become 76.4%. And so the interpretation of this would be we are 95% confident that the proportion of whatever it is that you're studying, so notice that I'm not assigning any particular subject, but whatever proportion we're studying, regardless of the subject, falls between, or is between, 67.6% and 76.4%. And just for the record, this does not change in terms of the calculation. I'm also going to show you the same calculation on the TI. So using the TI, if I'm doing a one prop z int, which is what I'm showing you here, okay, our x value 0.72 times 400, let's see what we get. Hopefully we don't get any decimals. Perfect. We're doing this out of 400, and we are using 95% confidence. So notice our values. Same thing you got. So it's much easier with the calculator. There are other programs out there that you can use, and like I said, I'm not here to make your life miserable. If anything, I want you to understand that this is really simple. You know, as long as you meet the random condition, and as long as you also you know, follow the conditions, that it has to, all trials are independent, the trials are fixed, all of the binomial distribution conditions. Now there's one more thing I want to show you, and I think I shared this with you, but I'm going to show you again. Okay, so let's go to confidence. Remember the Wabbit emu that I sent you? Because that means that all of you have access to a free TI 8384 calculator. So look, there's Math is Fun, and there's that Math Cracker one that I like using. But let's use Math is Fun, because Math is Fun is a good one to use. So we're going to put in our data just the way it asked us to. So notice that it's asking what kind of data we have. So it's asking, do you have a mean and a standard deviation, or do you have raw data? So if your data is raw, you just simply put it in here. I'm going to go back to the first example we did. So in our sample for the first question I did with you, we had, let me see what I did. I don't remember. Let's go down, show up. Okay, so I could just do the data to show you. So if I do this and I do control copy, let's go back to the calculator. Calculator. Okay, so let's go to raw data. I'm just going to dump it in there. And so what you basically have to do is separate your data with a comma. Okay, so you'll notice there sample size is 10 because the comma separate this. The sample mean is rounded to 304 and the standard deviation 116, 95% confidence. So according to this would be between 232 and 376. What did we get? 232 and 376. It's a little different, isn't it? Slightly off because it's using 71 for the margin of error. So, interesting. Let me put it side by side so you can compare. Let's pop this over. And then we'll pop this page over. There we are. I'm going to pull it down so you can see everything, but it's not cooperating very nicely. This is... Okay. So, take a look here. Let me push this over. Oh my gosh. I'm so sorry for that. It's wasting a few minutes of our time. There we go. Okay, so you notice our averages are not very different. What is a little different is it's calculating the confidence at 0.95. Okay, and I believe that's what we used for the margin of error. So we did use 0.95. Let me change this to 0.025. Maybe that's not recognizing the two-tail. So let's see. Let's just experiment since I have you with me here. And so now do we match what it said? Let's see. Let's go up a little bit. No, it's still slightly off, isn't it? It's saying 205, so I wouldn't change that. I would still use what I used. Because that is, I've seen this before, and that's how you do it. So, that tells me that maybe you might not want to use this part or this process, maybe use this process. But in either case, one thing I do know is that based on the two different ways of approaching the calculation, you may end up with a slight variation, okay, between the two. Alright, so that's what I have for you with confidence intervals. Just remember that the trials are independent for confidence intervals. And if it's a one prop, by the way, like a one proportion confidence interval. And then they have tons of calculators for this. Confidence interval calculator for one proportion. Any of these would work. Math Cracker I showed you, I don't know if you just saw it, it was just there. But there's tons of calculators online for this as well. Now, just out of curiosity, if you want to see this with the TI, I'll do this one with the TI. So if I go to Stat, and under Edit, let me put this in List 3. So we'll start with... is it 244, 254, 351, 254, 143, 234, 543, 234 again. That would be our mode. 365 and 421. 10 total data sets. So you notice that I have raw data in list 3 in this case, right? So what I would do, since I'm going to have a mean and a standard deviation, I'm going to go to stat test, and I'm simply going to do a z interval. This is one sample basically. And since I'm using data, I'm coming over to data. Alright, and it is asking me for a sigma. So let's say hypothetically, I don't know if I want to use that. Let me see. Let me go to another test. Let me see if I have another one we can use. It's a little less cumbersome. It's not a proportion. It's not a t interval. Yeah, so I guess you would use that one. Maybe because it's small. Maybe t interval? I don't know. Yeah, just use t interval. So, because we don't have the sigma, we're just going to use the t. We're going to use list 3. So what you would do is here, you come down, and you go second 3. And if you, once you hit the second 3, notice it's basically giving you list 3. And again, 95% confidence, calculate, let's see what we get. Yeah, see? It matches our calculation perfectly. Alright, so I hope this is helpful to you, and it's 21 minutes in length or so, so, you know, half of it, it's kind of like bouncing around. Enjoy.